Hey there, hope you're having an awesome day. So in the previous unit we were through with electric fields, and that is actually a prerequisite for this chapter that we are going to start now, right? So if you don't know electric fields, this chapter can be slightly uncomfortable to work with. So it's good if you know electric fields, because some part of this chapter is actually you cannot understand it if you do not know the ideas about electric fields. But anyway, this is the new chapter that we are going to be starting with, called capacitance. The prereq for this is electric fields. Now capacitance, the idea of capacitance basically gives rise to a circuit device, right? A device called a capacitor. And the symbol of a capacitor looks something like this, right? So this is basically a capacitor, and here you have some potential difference, which is stored through some distance. So first let's just talk about the ideas of capacitors and where do we see them in real life. All of these are different types of capacitors, and this is also this picture is not exhaustive. There are also other types of capacitors, actually something called variable capacitors, which do exist but they're not in this picture. So we have capacitors in a lot of appliances. Obviously you must be watching this on a smartphone or on a tablet or on a computer, all of which have many capacitors which are required for their working. So this is also required of you in your syllabus, that you know what are the uses of capacitors, right? Where do we actually see the applications of these in real life? Now one of the most important applications is in power supplies. So power supplies, basically to regulate and to protect the power supplies as well, you need capacitors. In tuning circuits, you need capacitors. So for example, if you're sitting in your car and if you're turning around the knob for switching the channel on the radio, basically what you are doing is you are selecting some different values of capacitances to help you pick up that particular frequency on the radio. This is also used in something called the smoothing, which is something we are going to study later in the chapter of alternating currents. So basically if you have AC current, capacitors can help to smooth that current, basically make it look more like DC. This can also be used for adding time delays wherever required. So if you want something to happen after a certain time, you use capacitors in that case. And then also for the purposes of filtering out noise, and by noise I don't just mean noise you can hear, because when you talk about signal processing, there's a lot of basically something like trash that comes along with the signal. So then to get rid of that signal, so to get rid of that trash, you can basically use filters, and filters rely very heavily on capacitors. Now when we talk about what capacitors actually are and how they work, you will see that all the capacitors here have two legs, right? So these have two ends or two legs, and there's a reason for this. So now let's talk about the idea of a capacitor and what is its working principle. In very simple terms, what a capacitor really does is that it stores energy. And how do they store energy is basically by separating, or some people also call this redistributing, by separating charge. So we just talked about this idea that when we talk about capacitors, all of the capacitors that we saw above have two legs, right? Now each of those legs basically connect up with a plate. So for each of those plates, you basically have, so both of these plates are connected across some potential difference. So some potential difference is applied to both of these plates, which make them store equal and opposite charges, right? So both of these store some charge, and then what happens is that you know that from positive to negative, from higher to lower potential, you have electric field lines which exist between the two, right? So that electric field line basically gives rise to electric potential energy between these plates, right? And this is why I actually said in the start that electric fields is a prerequisite for this chapter. Now, how can we have something like this happening? How do we actually do this? How do we actually do this to a capacitor? So the idea is pretty simple, which is that simply we connect the capacitor across a battery, right? So a battery or a cell, we connect across a battery, across the capacitor, and this is what starts to happen. So these are the connecting wires of the battery, right? So this, and then this, this. So this is the battery. This is the capacitor. Again, looks very similar to the circuit symbol for a battery itself, and this is, for example, that battery, right? Now what happens is that this battery, we know how we talk about the terminals of a battery. So we know that the one which is the longer end is a positive terminal, this is the negative terminal. So also when we were studying electricity in AS, we said that the negative end basically supplies an excess of electrons, right? And a positive, the positive plate does quite the opposite, which is that it basically takes and it pulls electrons off of this end, right? So it gives this plate of the capacitor a positive charge, and then this negative end basically deposits electron onto the other plate, which gives this a negative charge, right? So then you have this idea that you have equal and opposite charges stored on both the plates. So equal and opposite charges on the plates. Now this is actually, this used to be the favorite, a favorite question of the examiners for a while, where the examiner often used to ask, why does the capacitor not store charge, but it stores energy, right? So the idea is this, that there is equal and opposite charge on both the plates. So then the net charge is 0. So you have some charge, let's say this is positive Q on the positively charged plate, then you have the same charge negative Q on the negatively charged plate. So overall there is no charge. But we just talked about this idea that energy is stored by separating the charge, and energy is stored by the action of the battery, which basically does work in taking electrons off of this plate and depositing them onto the other plate, right? So work is done by the battery in this, which basically causes the separation of charge and hence energy to be stored. I'm just going to write this in words here. So capacitors store energy, not charge. And the reasoning we just discussed is this. So both plates have equal and opposite charges, so net charge is 0, but work is done by the battery in transferring electrons, because electrons are the main reason for the flow of current. So electrons between the plates. Now another thing about the working of the capacitor which you need to know is this, that if this is the EMF of the battery V, right? So this is some battery which is connected here, could be a 9 volt, could be a 12 volt cell. And till when does this process go on of charging this capacitor? So by the way, this process in which we are actually depositing charge onto one plate, actually this one, so you're depositing it onto one plate and taking it off the other plate, is basically called the process of charging a capacitor. So this goes on until whatever this EMF is starts to appear totally between these two plates. So when the voltage across these plates also become equal to V is when the charging of this capacitor stops. And basically on a molecular level you can think about it like this, that we know that this is the direction in which electrons are being transferred, right? So this is the flow of electrons like this. So the idea is this, that when you are taking electrons of this and when it has a large enough positive charge, so the positive charges here will basically be attracting the electrons and will not let it escape. And basically here when the electrons are being deposited, when there are enough electrons here, they would provide a very strong force of repulsion and it would not allow any more electrons to be deposited, right? So in that case, so initially when this is connected, there would be current flowing, right? So this is the direction in which electrons are flowing. So we know current flow would be opposite, that would be from positive to negative, and that stops until both of these have the same voltage across them, at which you know that there's not going to be any more potential difference between both of these components, and then no current would flow, right? So charging goes on until the EMF of the battery, whatever that is, appears as the potential difference across the capacitor. So you can see these ideas in a diagram like this, and at this point it's also good to introduce something that will be used a lot in your exams as well when the examiner poses a question. So this thing is basically called a three-way switch, and everything other than this in this circuit diagram is pretty much standard. So this is a three-way switch. So what is being shown here in this diagram is initially the switch is in this position. So this circuit part is basically active. So the positive voltage supply is basically making this end of the capacitor positive, and then this one is making this end negative. And we just talked about the idea as to how long does this process go on. So it goes on until whatever this voltage is said to be, that appears across the capacitor, right? And when this happens, we know what would happen, and we'll talk about this in the upcoming lectures as well, is that basically there's no potential difference, so current stops flowing. And then if I hit the switch and make it come to this position, right? So if instead of this, if I scratch this and instead make it come to this position, so now this part of the circuit would be active, right? And one of the major uses of capacitors, actually very large capacitors, is that they work as temporary power supplies. So then what would happen is that this capacitor, and the technical term for it is this, that this capacitor would start discharging, right? It basically releases its charge, and then positive to negative, the current would flow like this and make this bulb light up. So in the next video, we'll be continuing with our mathematical analysis of capacitances, how capacitances are defined, and so on.